What do you call something that is colorful and smart? A rainbow. That was a terrible joke, but it still works. Hey, it's me, Miss Billman, and we're looking at the Unit 5, Lesson 8 homework. During this unit, we looked at the distributive property, and in my mind, we distribute and then we can take away with common factors. So when I distribute the x to the x, I get x squared, and the x to the 3, so it should be x squared plus 3x. It is multiplication when I'm distributing like that. Now, no, there's nothing to distribute, but I do have a common factor of y. Once I take out that y, I get 4 plus 7. If I distribute that y back, I will get the same answer of 4y plus 7y. The distributive property is kind of like a cycle that you can do multiple times and you still get the same answer if you're doing it correctly. For number 3, it is the difference of y and 2 multiplied by x. So I distribute the x and I get xy or yx minus 2y. For number 4, it is 12 multiplied by the sum of x and 5. I distribute and I get 12x plus 60. So that's when I multiply 5 by 12. I could also write 12 times 5, but if I want to get down to kind of like the simplest form, I would write 12x plus 60. For number 5, 3x minus 6. So the greatest common factor that they have here is the 3. But you're like, whoa, there isn't another 3. But 3 is a factor of 6. So I take out that 3 and I get x minus 2. Because if I were to redistribute it, I would get 3x minus 6, the same expression I started with. Okay, 4x squared minus x. And that's when I distribute it. On here, the common factor is a 3. So if I take out the 3, I'm left with y plus z. I just use the same operations that are left in there. And if I were to redistribute, I'd get the same answer. The common factor here is x. I take the x out, and I get y plus z multiplied by x. For numbers 9 and 10, we'll be looking at greatest common factor. So please keep in mind with that, it's the largest number that goes into both of them. Sometimes it's easier to make a list. So with these numbers, like I just happen to know them off the top of my head, but you could also use a multiplication table. Okay, so for 48 and 42, we're looking for the greatest number that goes inside it. And it's going to be 6, because 6 multiplied by 8 equals 48, and 6 multiplied by 7 gives me 42. So if I take that 6 out, I'm left with 8 plus 7 multiplied by 6, or 6 times 15. The greatest common factor for 35 and 15 is 5, and 5 times 7 is 35, plus 5 times 3, which is 15. I take out the common factor of 5, and I'm left with 7 plus 3, or 5 times 10, and that'd give me 50. If I went through and added 35 and 15 together, I would get 50. So now we're going to see if these expressions are equivalent. So 4xy and 4x 4y, those are not equivalent. 9 plus the sum of x and y times 2. I distribute and I get 9 plus 2x plus 2y. Whoa, that's the same thing over there. Let's look at number 13. If I combine like terms, meaning the 2 and the 3, I get 2m plus 5, which is the same expression, so those are equivalent. For number 14, I'm going to have to distribute, and I'm going to have to, if I wanted to, I could find and combine like terms. So this I already got down to 2 plus 2m plus 3, which is the same as the left-hand side. Now we have 2 plus 2m plus 3 and 4m plus 3. Well, those are not equivalent because I can't get 4m by adding a 2 and a 2m. Those don't go together. They cannot. Now we have the sum of 4 and x plus the sum of 4 and y. I distribute and I get 4x plus 4y. And what do you know? I noticed that it would be multiplication, not addition in the middle. So that is a no. That one was kind of deceiving though. So I'm going to distribute and then write the coefficient in the front. So I distribute the 5x to the 2x and I get 10x squared with a coefficient of 10. Remember, a coefficient can't be a letter. I distribute the 2 and I get 6y with a coefficient of 6. Now this one has 2 letters. I still distribute. I get 6 times 5, which is 30, and jk, but I'm not kidding about that, and I get 30